Hello and happy Thursday, everyone. Good morning, good afternoon, good evening, wherever you are in mind, body, and spirit. Welcome to DORMER Pramet's Milling Matters. This is our second of 3 webinars. This one is about shoulder milling with versatility that delivers value. Before we start real quick, I want to say, let's talk about live captions. So this webinar today, just like last week's webinar and the webinar next week, they're going to be in English. So this is in English. You, as our valuable partner and customer, you have the option to change what language the captions are being shown in. So you can do that by going down and to the right. Over in the right, there is the gear icon that says settings. You can click on that and you can change the caption language to the local language you would like to be seeing and reading at the bottom of the live captions. Please do not change the spoken language. It will continue to be English. You can change the caption language to whatever your local language is, so it's easier for you to read and understand. Wonderful. Then with having said that, once again, welcome. And to those who have just joined, welcome again. First of all, at DORMER Pramet, it is safety first. Safety is very important to us. Who's important? You're important. So please be in a safe zone. Know your surroundings. Be sure that you're safe in mind, body, and spirit, and that also you're here with us present today. Please do ask questions. We want you to be comfortable with not just what we're saying and who we are, but with milling. So if you have questions, please do answer them. And on to that, let's talk about how you can ask questions. We'll have a 20-minute overview of our topic. We'll have a 5-minute Q&A at the end. The recording of this will be available after, and so you'll get an email shortly with the recording of this as well. You can ask questions at any time by using the Q&A functionality at the top of the screen. So you can click the Q&A and submit your questions at any point in time. And once again, I already mentioned the live captions, but let me mention it again to those who maybe joined us a little bit late. These presentations will be given in English. You can change the captions at the bottom to be in your local language. And you can do that by going to the settings at the bottom and clicking caption language and changing it to your local language. Once again, please do not change the spoken language. It will continue to be English. Fabulous, wonderful. Well, then let's move on. So for this 3-part Milling Matters webinar series, we have our colleagues, Christian Andert, who is not with us today here, but he's our training specialist. You'll get to see him later on at another one. We have here joining us today, Eric. So Eric Gerringer is our product and application manager, and he's going to lead you through today's Milling Matters. Once again, this is part of a 3-part series. Here today is our second part, and we'll be talking about shoulder milling with versatility that delivers value. And having said that, let me pass it over to my amazing colleague, Eric. Eric, take it over.
Thank you, Miriam. So just we'll touch briefly. So hopefully everybody was able to join us last week and remembers the kind of 4 areas of milling we discussed. But as Miriam said, today we're going to focus on the shoulder milling and the versatility of shoulder milling. And we'll touch on some areas such as the some milling methods and the versatility in the shoulder milling. And then so from the indexable shoulder milling applications, you start out basically, and you can also, from the perspective from general shoulder milling, think about the solid carbide or even HSS or cobalt in some instances where you need that long AP or that long length of cut. We'll touch a little bit on some repeated shoulder milling using end mills and face mills. We'll talk about some deep shoulder milling as well. We'll touch on that using the helical style cutter, the long edge cutters with the inserts up the side. And we'll also touch briefly on some peripheral milling as well. So And then so let's talk about the indexable shoulder mill applications. So here you'll see, we just spoke about the peripheral milling, very common application. When you think about that, typically you're using end mills, usually smaller diameter cutters when you're doing peripheral milling. Of course, it depends on your workpiece. You could be using large diameter cutters, but typically it's an end mill application. And some customers will even use the solid carbide or, like I said, the HSS or the cobalt end mills as well when they're looking for that fine finish or a really nice finish with no step overs from stepping down. But again, when you think about the indexable, the versatility that's going to give you versus a solid tool, you're going to be able to do many more things with that. And when you look at your cost efficiency, you're definitely going to be a little bit better shape from a costing perspective. And then over in the middle area, so we look at more of what I would consider more of the standard types of applications of face milling. So you're typically, when you're talking about the shoulder milling part of it, you're typically milling a face and you're milling a shoulder. So you're looking for that surface, that shoulder, and then a lot of times you have a radius call out as well. So again, this concept offers those extra geometries and radii to suit your needs. And then one thing you'll see, not as common, but it is used when you think about face milling, is disc milling cutters. So, I like to bring that up because it's one of those things to kind of keep in your back pocket. Don't forget about it. If you have to reach through a large diameter bore and maybe do like a shoulder milling application, like a counter bore, or if you even have like a large diameter workpiece or a large workpiece, you want to mill the face, something like that, or do the normal face milling application, or not a face milling, but a shoulder milling application. It's going to give you that extra versatility. And maybe you already have one of these cutters and you can use it in that application. And then, also with the indexable shoulder milling, you can't never forget about the deep shoulder milling. So when you think about deep shoulder milling, and there's a lot of terminology used in the industry. So you think about the helical mills, that's a pretty common term. And you'll see here the term long edge milling cutters. These cutters will typically have multiple inserts up the sides of the inserts, as you see here. And they're very common to see in roughing types of applications where you're doing shoulder milling, or maybe peripheral milling is also a very common application for these type cutters. The nice thing about these cutters is you're going to be able to machine shoulder mill a large area, a large length of cut in one pass. However, one thing though to verify, and I always encourage customers to think about this, when you look at a cutter concept like this, always think about your setup. Is my fixturing strong enough to support this type of fixture? And do I have enough horsepower? Do I have enough rigidity in my machine? And we'll talk about that a little bit later in the webinar. But those are just kind of some of the concepts to think about when you're thinking about that shoulder milling, or and again, the versatility this cutter is going to give you as well, from doing bores to shoulder milling to peripheral milling. So yeah, so let's kind of get into some of the methods on the next slide here, talking about slot milling. And when you get into slot milling, when you're using the shoulder mills or shoulder end mills, a lot of time is what most of us are doing. You think about, you know, what are some of the methods I see? What are some of the methods that are available to me? And, a lot of customers, you think about a perspective of, I'm doing a slot, I'm using a solid tool. You're looking at typically more cost. So I can use an indexable end mill, shoulder mill. And, you think about the conventional slot milling method is what we typically see on softer materials, if like your steels, even like some irons and things like that. That's just it's very very easy to program. Uh, it's it's one of the most common methods you see. Uh, and it's just basically you're moving straight into the workpiece and straight into the slot. But one of the negatives of this, it does create the most radial cutting forces. So you could potentially see cutter deflection. That will impact your surface finishes. The other thing is you will see on really gummy, sticky materials, you could get chip jamming if you try to use too dense of a cutter, a heavy pitch cutter. You typically want to use more of a medium or a coarse pitch type cutter when you're conventional slot milling. So, and then in the middle there is a technique that's become a lot more common over the last, I'm going to say last decade. It's been around for a while, but when you get into your heat resistant superalloys, die and mold machining, the trochoidal milling is a method that's been around for years, but it's becoming much more common with the CAD/CAM systems. So with this method, you are in and out of the cut. You're making a lot of tiny little circles over and over as you move that slot forward. And what that does, that allows you to increase your speed, your feed rates, because you're getting that chip thinning effect in the application area of this type of slot. And it also helps you evacuate the chips out at a much higher rate versus a conventional slot milling. But again, to me, one of the downsides to this is the programming method. So if you had to hand program this, it would be quite a challenge. However, but today, with today's technology, almost every customer that would this machining these types of materials, you're typically looking at you're using some kind of a CAM package. And so once you get into the CAM packages, this becomes much easier to program. So you'll get better tool life and also potentially faster cycle times as well. And then last but not least is a method that's not quite as common when you talk about the plunge milling. When you get into slots, this is something you have to be aware of your step overs because of the AE on the insert. That comes into play. Not all cutters can have the capability to plunge. But you think about if I have a really long tool or a really long reach, this cutter, not this cutter, but this method works really well with a shoulder cutter because you can plunge straight down into the part, and that's going to give you the most rigidity and the least amount of deflection because all your cutting forces are going straight back up in the spindle. So, this is one where if you have an end mill that's got a long overhang or you have a really weak setup, this is a solution you might want to consider. Now, and then when you get into you thinking about, okay, my positives and negatives, this is fairly easy to program. But from a negative aspect, where the other two methods with conventional and trochoidal, you can produce a finished slot using those methods. With the plunge milling, you're going to have to go back and do some type of a semi-finish or a finished pass to get that true slot wall, that 90 degree. Because this method is going to leave the scallops, as you can see in the picture. But again, with those long overhangs, with the vibrations, this is going to be a really good method to kind of get you out of a jam. So, okay, so let's talk about how, from a versatile perspective, how versatile the shoulder mills can be. So I really like this slide. It gives you a fantastic overview when you start talking about shoulder milling cutters and some of the application areas that you can apply it in. So, and when we get into, we'll talk about this in just a minute as well, but also one of the things you have to be aware of when you are thinking about a shoulder mill is exactly these pictures here. Am I only going to be shoulder milling, and am I going to be deep shoulder milling? Do I need to ramp? Do I need to be slotting? Am I going to be doing helical interpolation, opening up maybe a bore diameter? Those are the types of things you need to take into consideration. Because when you get into the cutter geometry, that we spoke about last week, and you get into the insert geometry. So if you have a single-sided positive insert, and you're talking about a negative positive cutter, it's going to be a single-sided insert. It's going to give you the most flexibility. Now, when you get into a shoulder mill that's typically what we would call a double-sided insert and maybe a negative concept, you're going to lose some of your flexibility, such as ramping, or you're going to have really shallow ramping angles. So, always think about your process and think about the application demands that you're going to have for your cutter that you're selecting. That's kind of critical when you think about it is, do I want one cutter to do everything, or do I want multiple cutters? What fits my work style or my shop? And then also, what's going to meet my customers' demands from the print expectations, such as surface finish? Do I need a true 90 degree, or can I get by with maybe an 88 degree shoulder? And then also to think about the machining recommendations for our next kind of talking point. So, and this is really, really a big one. When you get into the machining recommendations, some things to consider. All the different types of milling applications. When you talk about face mills, end mills, the helical mills, you get into just about anything like we just discussed with the different versatility of a shoulder mill. So when you get into that, like I said, always make sure that you want to select the right cutter for you. So that's a big one. And then also you want to think about, as I've briefly touched on before, when you get into larger diameter cutters, when you get into multiple teeth cutters with these helical cutters, does my machine have enough horsepower? Does my machine have enough feed rate? Can my fixturing stand up and hold that workpiece to machine at the feed rates that are recommended for these types of cutters? So always take that into consideration. And then next, when you think about the milling strategy that you're going to use, think about the impact that's going to have. One of the things I always like to discuss with customers is when you talk about milling strategy, you want to try to arc into your cut, arc out of your cut. If you come in just straight milling in a straight line, you will typically get some deflection, no matter how rigid your setup is, and that will affect your surface finish on your wall and on your face. So just be aware of that in your thought process of cutter selection, again, from your diameter and also from your pitch. When you talk about a light, medium, and heavy pitch cutter, put some thought into that. But again, you want that continuous engagement, and that's what we were trying to kind of show with this picture. Is if you notice right at the beginning, it kind of shows that a little bit of an arc coming into the workpiece. So I'll always encourage stay engaged in the workpiece. And then when you think about the machine tool holder, this is a really big one that gets, I'll say, kind of overlooked or maybe passed over sometimes. You think about the shortest possible. We always think about that. But one thing you might want to take into consideration, especially with your face mills, is when you get into the face mill mount type, is to think about the overall length, but then also possibly when you get into like a helical shoulder mill, think about the integral shank where it's all one piece. It could be HSK or SK taper, doesn't really matter. But think about from that perspective, is this something that I need that extra rigidity to support the material that I'm machining? I typically, anytime I get into a helical milling application, I always encourage the customer to go integral where possible. It's not always possible. It's not always feasible. It always doesn't make sense, but that will give you the best start or the least amount of problems from a vibration and also rigidity perspective. Okay. And then I want to leave you with an example of one of our kind of a most versatile concept. And so this concept is what we call a Force AD. It's an AP style concept. It's very common in the market. This is, and this was back a couple slides when we were talking about the ramping and the versatility of shoulder milling. This is one of the most versatile cutters concepts in the marketplace. I mean, and you can see here, I think this slide does a really good job. It puts together a really big overview of the different. So there's actually 3 different size concepts, size inserts that fit into this concept. So this as a whole, it does require different cutters. So like the 07, the SAT 07 insert doesn't fit into the SAT 11 or the SAT 16. They do require different inserts because that drives your depth of cut, your shoulder height, length. So, but this cutter, you can do pretty much anything you want to do with it, from ramping at really steep angles. And keep in mind when we talk about ramping with a concept such as this, so this is a negative positive on the body, but it's positive geometry on the insert, and it's a positive insert, so it has a lot of clearance. So as you want to increase your ramp angle, you're going to have to go down on cutter diameter. And that's kind of a rule of thumb for every concept that's out there that does ramping. So if I want to use a 25 millimeter end mill, I can use a much steeper ramp angle than if I use a 50 millimeter face mill or a shoulder mill mount. So I wanted to always, think about that. And again, it goes back to the concept. What concept fits my needs? What concept is going to give me the finishes, the print requirements that my customer is expecting, that my end customer is expecting, or that I'm expecting in my workshop? So, so the other benefit of a concept like this that it has is material types. So you get into the material types of aluminum, of heat resistant super alloys, to steel, to stainless, to irons. There's grades and geometries from roughing to medium to finishing geometries that are up sharper to support all the material types in a shoulder milling concept such as this. So this is, like I said before, this is one of the most versatile concepts on the market. And I'm sure everybody on the call has seen a cutter similar to this or has many of these cutters in their workshops. But again, this is, I think, one of the best representations of a shoulder mill when you think about the versatility of the shoulder mill and what your needs are and what it can provide you. So, and with that, I'll hand it back over to Miriam to hopefully try to answer any questions or comments.
Great job. Thank you so much, Eric. Thank you. And thank you, everybody, for your participation, your engagement. We do have a few questions here, but please, we will be here for a few more minutes. So if you do have some questions, please do chat them in the Q&A up there. So let's get to some questions then, Mr. Eric. So first of all, we have a question about plunge milling, actually.
Okay.
So we have a question about speeds and feeds for plunge milling. And the question is, are lower speeds and feeds per tooth recommended for plunge milling?
Typically, yes. So it all depends on the application of the materials. So I would typically recommend plunge milling. So if you're talking about slotting or just plunging on the edge with a shoulder mill, you're typically going to run slower RPMs because you're typically using that because you're having vibrations, or maybe the spindle's not the greatest condition in the world. But the short answer would be yes. You would typically want to try to run lower feed rates and lower surface footages to keep your vibration at a minimum.
Good answer. Thank you so much. And a good question to our participants. So we do have one more question before we end, and it's about the milling pass versus the milling cutting diameter. So is there a general rule of thumb for the offset of the milling pass?
Yeah, so I won't say, I hate to say there's always a general rule of thumb, because I think in this day and time, when I think back to the 80s and 90s, there was those general rule of thumbs. But today, as we get into, almost every customer is using a CAM package. Some are using super complex CAM packages. Some are using more affordable CAM packages that really get it done at a better cost. So I don't think there is no industry rule of thumb that I've ever seen. Every customer does it a little bit differently, but usually you want to stay, when you're talking about shoulder milling, you want to be at that 40% or over. You never want to be in that 40 to 60% realm on a shoulder milled engagement when you're rolling in and out of the cut. That is, I don't know if it's the proper term, but I call it the harmonic vibration zone. So typically with a shoulder mill, you're going to get into an area where you're on the center line of that cutter, and you're going to create the most vibrations and the worst harmonics possible. So, think about that from that perspective of what do my finishes or requirement. So that 40 to 60% plus, either 40% minus or 60% plus is where you typically want to be.
Got it. Fabulous. Thank you. Since we have some more time here, we're going to get to some more questions. So thank you to everybody who's posting questions. We also have people answering questions. So go team, virtual high fives. Another question is another plunge milling question. The maximum depth of cut during plunge milling. What are your thoughts, Mr. Eric?
So it depends on the concept. So your type of insert in shoulder milling. So if I think about, it could be just about any kind of concept. You could use like a square insert. You could use the rectangle inserts. So that width of insert is going to be your plunge width step over. So if you're using a 12 millimeter insert, you could go up to probably 10 or 11 millimeters on your plunge width, for instance, if that across the bottom. But be aware now, when you're thinking about plunge milling, all concepts, if you're using a true 90 degree, you're going to have that flatter bottom. But some of the shoulder milling concepts are at 88 degrees, or the angle is not exactly 90. So just, put some thought and consideration into that as well.
Got it. So one final question. We have only a minute left. So the question, and actually it's a question from last week's webinar that we didn't get to answer. And it says some cutters come with shims and some don't. What's the rule of thumb with that?
So typically, you don't want to use, so from a density perspective, how many inserts can I get into the cutter? And then also when you think about that, you don't want to use, there is no rule of thumb, but when you think about a heavier type cutter that's doing heavy roughing, or a cutter that's like typically used for face milling, you see more of the shim seats, the shims and the inserts. So those concepts are typically lean more towards the heavy roughing, and the concepts without the shims typically lean more towards what I would call medium machining or finish machining.
Got it. Wonderful. Excellent answer and great question to our participants, and wonderful, great questions to everybody who participated. Thank you so much. If you want to continue to post your questions, we'll try to answer them at a later time. But if you do want to, you can also reach out to your local sales team member. We have sales team members around the world to support you, not only in this call, but wherever you are. Or you can reach out directly to our wonderful presenters. So you can reach out to Eric or to Christian, like I said, who will be joining us at a later time. You can go online, browse our assortment, and of course, register for next week's webinar, the third of our 3-part series on milling matters. And then you'll also get a link to rewatch today's webinar. So thank you, everybody. Thank you, Eric, for the wonderful education. Thank you, everybody, for joining us. Have a wonderful day. Be safe, be happy, be healthful, and be well. And we will be seeing you next week again.
Thank you, everybody.
Thanks. All the best. Bye-bye.